In this video, on Chapter 1.7, Solving Quadratic Equations, I will continue on the lecture from last week on solving quadratic equations. Question number 1, x squared plus 14x plus 24 is equal to 0. I can see, with the leading coefficient of 1, 1x squared, I'm going to use a simple cross product algorithm. 1 times 24 is 24, and the middle is 14. Get into the habit with writing out the list, as this will be your best friend with working out the question. The list of 24, so I'm going to write out the factors. So 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. I can see that 2 times 12, 24, is also the same thing as 2 plus 12 is equal to 14. So I'm going to put in 2 and 12, and the two binomials become x plus 2 and x plus 12. From here, we're going to split up the two parentheses, so we have two small problems. This reads x plus 2 is equal to 0, and x plus 12 is equal to 0. Simple algebra from here, so I'm going to subtract 2 to both sides, and x is equal to negative 2. The same thing with this. I'm going to subtract 12 to both sides, and x is equal to negative 12. Just to make sure that your answers are indeed correct, you can plug your x's in. It doesn't always have to be x, it can be any letter from the alphabet, making sure that your answers are indeed correct. So I'm going to place this as negative 2 to the second power plus 14 times it by negative 2 plus 24 should give us to 0. So negative 2 to the second, so that's 4. 14 times negative 2 is negative 28, plus 24 is equal to 0, and I'm going to subtract 4 and 28, which is negative 24. And I can see that 0 is indeed equal to 0, so therefore x equals negative 2 is correct. And you can do the same thing with x equals negative 2, so get into the habit with checking your work. This question, x3 minus 5x squared minus 6x is equal to 0. See that your numbers have a common factor of x from all three terms. So I'm going to split and extrapolate the x out, and everything else that we haven't touched will remain inside. If we take 1x less from x3, now it becomes x squared. If we take 1x less from 5x squared, it becomes 5x. If we take 1x less from 6x, it becomes negative 6. The inside, I can see this is 1x squared, so I'm going to use the simple cross product algorithm. Beginning times end, the middle, list, the list of negative 6. So it's 1 and negative 6, 2 and negative 3. Not only that, but we can do it the other way around. Negative 1 and 6, and negative 2, 3. From here, I can see that 1 plus a negative 6 is negative 5, which is what we need. So this is 1 and negative 6. So the two binomials becomes x plus 1 and x minus 6 is equal to 0. But let's not forget about the x that we extrapolated earlier. That needs to be part with the sentence as well. Split, x is equal to 0, x plus 1 is equal to 0, and x minus 6 is equal to 0. X is equal to 0 is already set. All we need to do is just the simple algebra for the other two. So subtract 1 to both sides, and x is equal to negative 1. This, I'm going to add 6 to both sides, and this becomes x is equal to 6. So you have three answers. You can verify that your answers are indeed correct by plugging x equals 0 in for x to the whole sentence, making sure that this is 0 is equal to 0, and it should be. The same goes for negative 1 and 6. Up to this point, you should recognize when difference of perfect squares occur, so such questions as number 3 should be a little bit suspicious. 4x squared can be rewritten as 2x, this to the second power. You can verify that your 2x this to the second power is correct by distributing the 2 back in, and it should give you back 4x squared. 2 times 2 is 4, and x times x squared. The same will be done with 25. 25 is the same thing as 5 times 5, so I'm going to write it out as 5 to the second power. Up to this point, be sure to write out the theorem that you're going to use to go through the next step. The difference of perfect square theorem, and up to this point that gives you permission to use the next sentence. So 2x minus 5 and 2x plus 5 is equal to 0. From here, it's splitting up the parentheses to give you 2x minus 5 is equal to 0 and 2x plus 5 is equal to 0. Simple algebra, I'm going to add 5 to both sides. 2x is equal to 5, and I'm going to divide 2 to both sides. X is equal to 5 halves. Subtract 5 to both sides. 2x is equal to negative 5. I'm going to divide 2 to both sides. And this reads x equals negative 5 halves. Question number 4. 100x squared minus 9 is equal to 0. Again, be suspicious that this should read as a difference of perfect square. Let's just find out how it should be rewritten. 100 is the same thing as 10 times 10, so I'm going to rewrite it as 10x, this to the second power. And 9 is the same thing as 3 times 3, so I'm just going to lay it out with just 1 3 with the power of 2. From here, this is a perfect square, that's a perfect square, this is the difference, so we are allowed to use the difference of perfect square theorem. The 2 parentheses now becomes 10x minus 3, and 10x plus 3 is equal to 0. From here, we're going to split, and this becomes 10x minus 3 is equal to 0. 10x plus 3 is equal to 0. Simple algebra from here, so I'm going to add 3 to both sides. 10x is equal to 3, and we're going to divide 10 to both sides. X is equal to 3/10. So that's one answer. For this, I'm going to subtract 3 to both sides. 10x is equal to negative 3, and I'm going to divide 10 to both sides. X is equal to negative 3/10. And again, you can validate that your answers are indeed correct. I'll just work on this, and we can continue forward with the lesson. 100, this is 3 over 10 to the second power minus 9. Should give it to 0. I'm going to distribute the power of 2 to the top and the bottom of the fraction. This becomes 9 over 100. Times by 100 minus 9 is equal to 0. 100 over 100 cancels out, giving us 9 minus 9 is equal to 0. And that indeed gives us 0 is equal to 0. So you should feel confident that x equals 3 over 10 is your answer. And the same thing can be done with this. You can validate your work just to make sure that your answers are indeed correct. Question number 5. 10, 60, 80. There's a common factor of 10 that exists in all three terms. So I'm going to pull out the 10 and rewrite everything else that we haven't touched inside. 10 divided by 10 is 1, so 1y squared. 60 divided by 10 is negative 6y. And 80 divided by 10 is 8. From here, this is a leading coefficient of 1, so therefore I can use the cross product algorithm. Simple. 1 times 8 is 8, and the middle is negative 6. Get into the habit of writing out the list. 1 and 8, 2 and 4, and we can also go with the negatives. Negative 1, negative 8, negative 2, negative 4. I can see that the negative 2, negative 4 is equal to negative 6. So negative 2, negative 4. So the two parentheses becomes y is minus 2, and then y minus 4 is equal to 0. And let's not forget about the 10. From here, we're going to split. 10 is equal to 0. Y minus 2 is equal to 0. Y minus 4 is equal to 0. 10 is equal to 0 never exists. So I'm going to say no solution for this. Plus 2 plus 2. Y is equal to 2. I'm going to add 4 to both sides. 0 plus 4 is 4. So you have two solutions. You can verify that your answers are correct by plugging 2 in for x, or in this case, y. And the same thing can be done with 4. Question number 6. Assume that your ax squared plus bx plus c must always equal to 0. That's a rule. So we need to push the 30 to the other side. This one becomes 0, and this now is f squared plus 17f plus 30 is equal to 0. And then from here, simple algorithm, because that's a 1. 1 times 30 is 30, and this is a 17. And from here, get into the habit of writing out the list of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. The factors that add up to 17 is 2 and 15, so this becomes 2 and 15. F plus 2, f plus 15 is equal to 0. From here, I'm going to split, so this reads f plus 2 is equal to 0, f plus 15 is equal to 0, and I'm going to subtract the 2 to both sides, and this becomes f is equal to negative 2. This, I'm going to subtract 15 to both sides, and it reads f is equal to negative 15. Question number 7. Again, assume that this needs to be solved into ax squared plus bx plus c is equal to 0. So let's first distribute the x to both 3 and x. This reads 3x plus x squared, and rewrite everything else out. So negative 1, negative 3. Again, we need to push the negative 3 to the other side, so plus 3 cancels out. This is 0. Negative 1 plus 3 is 2. And I'm going to rearrange this as from leading coefficient to least. X squared plus 3x plus 2 is equal to 0. And from here, simple algorithm, because that's a 1. 1 times 2 is 2. The middle is 3. And the list, 2 is a pretty convenient number, because there's only one factor form, 1 and 2. 1 times 2 is 2, and 1 plus 2 is equal to 3. So that matches. So x plus 1 and x plus 2 is equal to 0. Split. X plus 1 is equal to 0, and x plus 2 is equal to 0. And simple algebra. Subtract 1 to both sides. This becomes x equals negative 1. And minus 2 minus 2. X is equal to negative 2. And again, we want to read question number 8 as ax squared plus bx plus c is equal to 0. Let's first distribute a z. 2z plus z squared plus 8z is equal to negative 25. I can combine like terms, 2z and 8z, which is 10z. I'll just rearrange a bit. Z squared plus 10z. And I'm going to add 25 to both sides. That way this becomes plus 25 is equal to 0. From here, it's a simple algorithm. 1 times 25 is 25, the middle is 10, and the list of 25 is 1 and 25, and 5 and 5. Now I can see 5 plus 5 is equal to 10, so this becomes 5 and 5. Z plus 5, z plus 5. The fact that both of the parentheses are the same, I'm going to only solve for one. Z plus 5 is equal to 0, and subtract 5 to both sides, and z is equal to negative 5.